Oh, alien dance. Yes, it's very good. Groovy, groovy. Why does it taste like that? It's like something is off. It's a big cup, so gotta drink all of that today so I can focus really hard on literally the hardest problem I've ever tried to solve. The first problem I've ever failed at solving. The coffee is peculiar indeed. Alright, so we're gonna go through a little Firefox crash. It just kinda does that. Thank you, Firefox. And then I need to press the buttons. All right, there is Stream Chat back. Okay, let's get right into it. I been putting this off for like 4 months or something like that. Yes, beautiful, beautiful. Okay, close all. Close, close, close. Okay, so engine physics. Oof, excuse me. Okay, so why don't I look at my notes? Oh God, what was that on the screen? Jesus. Okay, I like despise pop-ups of any kind for any reason. Okay, this, yes, issues, yes, 0 time collision start. Okay, discussed here, fixing Bing Bong flush face transfer. That's what I was thinking just now. MD algorithm possibly not returning correct results for exactly adjacent queries 6 months ago. Wow. Face crawler possibly not allowing 0 time events. Oh, within the algorithm. Okay. I'm sure I looked that over. Let's look it over again. Physics, face crawler. Yeah. Okay, so I have a bound here. Okay, what so let's start at the top here. This is the function signature next transition. What transition? What are we doing? What is going on? So I'm gonna need a prop for this. Okay, let me introduce you to the hardest problem I've ever solved. Ever not solved. Attempted to solve. It's my cube. Okay, so here's what it is. We only need one mesh because it's generic across meshes. Not really. but we can pretend that it's not a Minkowski sum of two meshes, and it still works. Okay, what is this? Next transition, it's called right here crawl. Okay, this is face crawling. So these are faces of a mesh, right? So we must be crawling across the faces by the name. Okay. So fev is face, edge, or vertex. So face, edge, or vertex. So you start at a face, edge, or vertex, and then you crawl along the mesh, following a trajectory. So the idea is that the trajectory is some sort of parabola, and you project it onto the surface of the mesh. Each face differently, or each edge differently. It's projected on the specific face, edge, or vertex that you are currently crawling. Vertex, it's projected into a point, but yeah. Okay, so you start. You have a lower bound and an upper bound. What is that? So that is valid time bounds for results. So did it hit the mesh? Did it miss the mesh? Really what we're doing is we're doing a parabolic raycast onto the mesh. And it's implemented in such a way that you're following this closest this point on the curve, on the trajectory. So you have a starting point, and it's like, oh, well, that's the closest point on the mesh is right here on that face. And then as you move along the trajectory, the closest point will follow it and move up the face onto the edge, and then move on to this edge and then hit as it goes like boom. And that is a transition. A transition is when it goes from face to edge, or edge to vertex, or vertex, edge, edge to face. It cannot go from face to vertex. That's two jumps. But that's not super important. Okay, so that's the overall loop. To do, fix all bugs. Don't make any mistakes. To do, okay. So when you call crawl, it computes these bounds, and then this should be an infinite loop, but it's busted, so it's not. It calls next transition repeatedly until it hits, then it returns, or misses, then it returns. So next transition, it just like goes to the next thing and calculates again. Okay, so in here, self is a fev, face, edge, or vertex. So which one? Which one is it? Okay, if it's a face, then we do this. If it's an edge, we do this. If it's a vertex, we do this. Okay. So when you're transitioning to the next fev, you see this one is face, and it only returns edge. You can only go from a face down to an edge. You can't go from a face down to a vertex. And then edge can go up to a face or down to a vertex. Vertex can only go up to an edge. There's no face transition there. If none. Break. Best transition. What is if none? I don't know. I wonder if that's a bug. Okay, so what is it actually doing? Okay, it's a face ID. Okay, so it's some face number inside of this mesh. So this is face 1, face 2, something like that. So ND is the normal and distance from origin. It's a dot product of the normal vector and any point on the face, on the plane. So you can represent a plane with 4 values instead of needing 6 to like represent a point on the plane. The dot product of any point on the plane and the plane's normal vector has the same result no matter which point on the plane you use. So we can just use the dot product of that as our plane representation. Okay, so this is the actual plane numbers. Okay. So then what's this? For dt in. So this is a quadratic solve in arbitrary precision, but notably fixed at compile time precision. So it knows the precision at compile time, but it is arbitrary precision. Or, well, it's one of these. Go back. I love the back button. Holy smokes, what a great discovery. Okay, how does this work? Use the mesh transform translation instead of baking it into the D value. Right, I wanted to change the D values to be relative to the like current calculation, current mesh. Because right now the D values are global, and that means they have to be higher precision because reasons. Oh gosh, it's a trait. Oh goodness. Okay, I'm not understanding something here. How do you know when you exited? Oh, this isn't that. Oh, okay. So this is like we have a parabola, and this is like we're looking at the face. Did the parabola intersect with the face? That's what this is. Okay, so there's a quadratic solve. So there's two solutions. So this for loop iterates twice, or 0 times or 1 time, and of a plane, a parabola intersects the plane in 2 positions. So one position is not on the face, but it's on the plane that the face it's there. It's there. So it intersects here, but we don't care about that. So we want to like make sure somehow that it's in the face. Am I not doing that? You what? I think there's some invariance in this algorithm. And the invariant is that the oh, there is no time value. Oh, okay. So there's no current position of the like closest point traced along the surface. It's just like the closest point is somewhere on the current face edge of vertex. Okay. I suppose that makes sense. So it's like a subset of the trajectory implied by the current fev. So it forms like a Voronoi column above the face or the edge. It's like this space. Okay. So then there's 2 solutions. The solution must be going into the face. It can't be coming out of the face. So I guess that's how I'm throwing away the bad solutions. Just extrapolated velocity ratio dt. Okay. So then the lower time bound is allowed to be unbounded. And it determines if it's in these bounds. So included bound, excluded bound. Uh, it this is going to heavily depend on the input state as to what it outputs. Do I have any? Yeah, I do have some parity calculations. Big oof. I wanted a branchless thing, but this is like mega slow. Times by -1. It's a huge number. It should just be negating. Yeah, but the problem is that it needs to be conditionally negating it. So I need like bitwise negation. So I can okay, don't get distracted. Don't get distracted. Renum bitwise negation. Okay. So that was the very first loop of the very first case. So it implies that we are handling the subset, the section of the trajectory that corresponds to the Voronoi column above the FEV. Okay. It's actually any continuous curve. So this should be a trajectory solve, huh? Trajectory solve ND. Yeah. So this should be like face and then trajectory solve face. Whoa. And then I can like have a trait bound and it'd be generic across any solvable curve, which would be a waste of compile time. Well, that's pretty cool. Okay, so for each face edge, so for each face edge, 1, 2, 3, 4. There's 4 face edges on that face. Okay. So there is the edge ID, and it's directed, so they have to point in a particular direction to correctly define the face. If they point in the wrong direction, then the face is inside out, and this calculation that calculates that the ray is going in to the face becomes backwards and is invalid. So there's several invariants here. Why don't I write this down? Find the next transition along trajectory. Given the current FEV corresponding to a Voronoi column, I could say intersecting the trajectory in encapsulate trajectory segment. Interesting. It's so like I always explain it like you're following the closest point, but this is not doing that at all. It's like discrete segments of the trajectory it just like finds the next discrete segment of the trajectory. It's like discretely tracking the closest point rather than continuously tracking the closest point. Okay, this is kind of poorly written, but like, okay, need more caffeine. I kind of diluted it with Chucky milk. So why is it doing this? Upper bound equals included. Why would you do that? Why? Okay, because if there is another Scoober Doober, if there's another solution, so this is like testing various transitions. So what is a transition? A transition is either a mist, the parabola mist, the raycast, parabolic raycast. Next, so you found the next segment of the trajectory to scan for collisions, or it hit. You actually found where it hit on the mesh. We were dealing with the blue face. Okay, so it changes the upper bound because let's say it like hits over here and it's like whoop, and we're like testing this face and it's like oh dude, there's a collision over there. It's like, okay, I'm gonna write down the upper bound is now this. The upper bound could have been like infinity, unbounded. So now we know that our next transition has to happen before that event that we found, that transition that we found where it hits. And for each face edge, this is the face we're looking at, edge, 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 edge. It checks to see if it crosses the plane for that edge. So it's going to hit before it intersects with the plane. And so it's going to override this earlier intersection thing, guaranteed. Unless the invariants were not met. I wonder if I can assert the invariance and find bugs like that. This function has some invariance. The trajectory is expected to have a segment that passes through the Voronoi column. It's like I made this up. Voronoi column. Can I? Hello? Can I? Hello? Hello? Oh, clipboard's broken, isn't it? Nice one, Zed. There's a Voronoi column. Lol. Yeah, no, it's not a real word. So this is a Voronoi diagram. So every pocket of this has a point that is closest to it. So similarly, what I mean by Voronoi column is one pocket of the three-dimensional Voronoi diagram for face edges and vertices. Face edge or vertex. So in the space around the mesh, in which pocket is this face always the closest? Well, it's going to be a column of air above this. That's what I mean by the Voronoi column. And then for this edge, it's going to be like a 90-degree wedge of air above the edge, and for the corner, it's going to be like a corner of air. So it's split up kind of like a Rubik's Cube. And I'm holding a Rubik's Cube. So imagine like a 3x3x3 Rubik's Cube, but like this is the center, and the corners have no edge. They just go on forever. So it's like a cube, and then a column here, column here, column here, column here, column here, column here, and then yeah. So there's a corresponding Voronoi column for every Rubik's Cube piece, except the core, and the core is like this current mesh. Cool. More caffeine. Okay, so bound included. So what does that mean? So can you replace if I say, oh yes, the upper bound is now this value. Giga time. Giga. Can it get replaced? And does that happen for... I don't know if I got all stack here. I think I'm like close to getting all stack. Okay, that's besides the point. Stack versus heap. Okay, so if it detects a collision here, and then this is the exact same number, what happened? Less than or equal to time included, then it becomes true. So if dt is less than or equal to so if it hits the very edge like this, oh, excuse me. Then it would also hit this, and this would replace it. Is that not a bug? Is that the bug? Would that help me? I do not know. I do not know. I do not know. If I say the bound no longer includes this time, is that bad? Is that bad? What if I run this one second? Because, like, I believe that a hit should take precedence over a transition to the next thing. If it's a valid hit and this doesn't occur sooner, but at the same time, then it should take the hit. Let's try it. Imagine, use the mesh transfer, breaking it into the D value. Imagine if this fixes the bug that I've had for 2 years. Just like 10th iteration of fresh eyes. Like I've come at this with fresh eyes 10 times. What is this? This is an edge. So to vertex overrides to edge. Probably it should be the other way around, but like, yeah. As ref impl copy. XD. What is that? Is never read. What? How do you know that? This is a for loop. It might read it on the next iteration. Is it just trolling me? I feel like it's trolling me. It does that a lot. Oh my goodness. But I think I had. It's not trolling. This is a for loop, my good fellow. It reads it on the next loop iteration, my good fellow. Maybe it is overwritten before being read. No. Look. It's the next loop iteration. God, is this serious? Seriously, like a Rust bug? Are you kidding? Okay, what's this? Oh my god, bro. Okay. It builded. Let's run the track. Strafe, 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 strafe. Alright. Imagine I don't fall. So what is the bug that I've been fighting for 2 years? The bug is that I fall through the ground before I reach the edge. So let's see. Okay, the bug still happens. Wait, I'm in the air? Why am I in the air? This shouldn't be activating strafes. That's not good. Oh, damn. Damn. So as you can see, the physics works pretty good, except for that one bug. And I haven't been able to fix it for 2 years. I've worked on a ton of other stuff in the meantime, but I can't have a game if you just fall through the ground. So I need to fix it. All right. What? It doesn't say why. Maybe it is overwritten before being read. No. Write, loop, read. Like, is that not just exactly the same as what? This has got to be trolling. Okay, let me think about this for edges. Oh, give me the prop. So if you're on an edge and the ray goes like, yeah. Interesting. That could be either face. Pick one. It does make sense to put it into a face rather than. Okay, so alternatively, what I could do here is I could say bound. The bound is excluded. And that means that you're not allowed to overwrite it if you find something at the same time. You're only allowed to overwrite it if you find something earlier in time, sooner. A collision happens sooner because it's finding the first collision. Sorted by time. Okay, I have no idea why it made up that that error message. No idea. Let's check BinRW. Did someone open an issue? XD. Cool. Okay. Okay, that built. Just check that this also doesn't magically fix the issue. Wait a second. Wait. Yeah. No. Okay. Okay, it doesn't. Imagine. Why am I? Why is it activating strafe text? That's bad. That is a regression. Uh, what was I thinking earlier? Invariance. Yes, I was thinking about the invariance, and I was thinking like, what if I asserted the invariance? Okay, trajectory is expected to have a segment that passes through the Voronoi column. Okay, whatever that means. And then, what else? Oh, it's hot. I gotta open a window. Oh, it's for the dot product, isn't it? Hmm. I wonder if it would be smart to put the math traits on the vector. Well, no, that would limit the way you could use it to be. Yeah, having the math traits per method is the most general. So like what I'm saying is I could have these traits on the type itself, trait bounds. Oh well, I guess no, I couldn't. Yeah. Right. So fix something. Right. Right. Because this only exists for certain ones. That's why. Okay, so that was the very first thing I saw. Is face crawler or no? It's very early. Okay, face crawler possibly not allowing zero time events. If you are exactly adjacent to a surface, but it's not in the contacts list, when you accelerate towards it, it will sometimes not detect the new collision. Uh, this needs to be a supported case partly for surf. Exact missed tests probably need to pass, and some new tests will need to be written. Okay, bro. from 6 months ago. Debug 35 branch. The algorithm cannot be modified to allow correct results for exact collisions. The algorithm. As soon as the surface is contact, it returns an incorrect result even when the inclusivity is changed. Right, okay, so this is the MD algorithm. So I did this. I don't know if it's merged or not. This function has some invariants. I really like that the condition is the same for all of them. It's juicer. I think this might have been excluded previously. Yeah. Oy, 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 oy. Let me try making it go away. 1 year, 2 months. 1 year, 6 months. Mesh query trait fev. Use bounds. Lead let less than. So I was using always less than. And then I changed it to be dynamic. Yes. So yeah, you could have like a trait that only has a very particular implementation, like, oh, it's the included bound. But then you can't change it dynamically at runtime. The type. Well, not at runtime. At compile time. You can't change the type like right here. You can't be like, oh, well, yeah, whatever the bound was before, now it's inclusive. So it has to be like that. Oh, cow. Huh. Huh. Question. Did I actually merge the goober code? No. Right? Where is that? Okay, you are done. You're done. This is good and done. I don't actually need the history. He said confidently. Oof. MD escape. Okay, so here's the MD escape. Let's see. Is that a pull request here? Yeah. Okay. Is it conflicting now? It is not. Cool. Okay, so we add. Oh goodness. What's this trait? Trait for triangle. Right. So we're doing okay. We're doing crazy stuff. Okay. Oh yeah, this algorithm is juiced. It just barely works out. Okay, that's freaking crazy algorithm. That's pretty clean. Not gonna lie. I thought it was like gooby, but this is freaking clean. The problem is that it's like always doing this work. And don't need to be doing like that. What did I write here? What? Why would it need to be a binary heap? Like, is this not? Oh, um, is this not like peak pop? Why is it not pop? I guess cause that like mutts it. Yeah, I mean this is like heaping twice. Not really. I don't know. So if I recall correctly, with the hope that it can be used to resolve zero-time collisions. Boy. And it didn't, and I freaking died 3 months ago. Oh, it's only been 3 months. I haven't neglected it for 6 months like I thought. Ah, this is a nice song. Because this is loggy and this is linear. But like, I really like things that have better time complexity in the limit. Vertices on the tip of the mesh. The faces are not necessarily on the surface. What a fantastic explanation. I had to read it twice to figure out what it actually means, but God, I would just have to rethink everything from scratch if I didn't write that down. This completes the algorithm. It completes the implementation. But like, yeah, the problem is that it's like always called, even if some fev, closest fev not inside. Oh, I'm literally just doing this for the exact calculation. Goodness gracious. Okay. So this just slows down everything for the singular case where they are adjacent. Yeah. And it like wasn't really 0 when I thought it was 0. This right here. R. How far ago did this branch? From right here? Woo! Look at the huge minus. Do I do Benum? Oh, there's Clippy fixes. Yeah. And then there's the whole Mafix thing. Alright, it's mostly just crud. It's not really crazy stuff. It's surprising that it merges cleanly. It's out of date, but it merges. JavaScript error. Nice one, dude. I guess it makes sense because it's like lib and stuff. And it's like barely touching the physics. And then this is all about the physics. This guy. It's like physics. That makes sense. Okay. Ugh. Get my fix of caffeine. Aye. What's up with this? Oh, okay. Yeah, coffee is like... I need to dump more sugar in there. Minus 600 lines of code is a big W. I guess this is... It's actually like plus 600 lines of code. Unlucky. Because like most of it is from this. R. So, okay. We want to know this. Is this 0 when I expect it to be 0? So I'm doing a calculation. And I remember watching the terminal output 3 months ago. And it was like really spammy and hard to read. But it was sometimes 0. And just, but like not always when I thought it would be. Expanded.norm. You what? Oh. Wait a second. I'm dealing with like I'm okay, hold on. Let me write this down. Um um why don't I put this in the last one? Uh uh I've been under the assumption that uh player is standing exactly on the surface, but I've seen evidence that this is not the case. That the player is sinking into the object at a nanoscopic speed. Endoscope, microscope, nanoscopic, microscopic. No. Nanoscopic. Sinking into the surface. So you don't stand directly on. Okay, so me wit. So that would mean that you're already intersecting with the surface, and the only reason you're standing on it is because it's in the contacts list. So that would be the fault of the walk algorithm, probably. Let's check it. Check. Or la. Contacts list. Print the penetration depth of all contacts, basically. Yeah. Touching state, basically. Collision start. We're not doing a collision start. I want to just like, oh, what's the summary, big bro? Instruction idle. Man. Yeah, no, I guess I do want to do it every single instruction. State, physics state. Alright, bro. This is atomic input instruction. Okay. What's atomic internal instruction? Sounds like you started colliding with something. So they're like separate. So then do I want to do it in the... But I can't see. I don't know, dude. Is there a function that both of these call? No, not really. I think it's kind of whatever, and I should just do it whatever. Alright. Print that body. How do I do this? What do I want to do? I don't know. Just do it. Like, it just doesn't matter. Just do it. Just print it. For contact in state.contacts. Hello? Hello? Touching. Yeah, contacts. Am I like doing something crazy here? I don't know. But no. Okay, what's this? It's a contact. Mesh ID and Minkowski face. Oh, how do I determine the penetration depth? I have to construct the Minkowski and then I don't actually know. God, my nose just wants to be touched. Alright, there you go. H1, H0. Okay, that's the wrong one. Oh, look at that. Okay, contacts, boom. Predict. No. Model mesh, convex mesh ID. Okay, something like this. Yeah, there you go. Now we're talking. Where are we at? Come on, man. Oh my god. The clipboard broke. Dude. Okay, what's up with that? Hitbox mesh. Who said that? Data. Alright, dude. Alright. Whatever. Is this like juicer? Complete mesh view. Yeah. Whatever. Just print it. Models. Who's that? Data dot models. Alright, dude. Okay. So now we have the mesh for which the face ID does have meaning. Ah. Face ND, right? And then it's the face ND. Whoa. So that's the N and the D. Does this want the big one? Yeah, okay, whatever. All right, so now it's in world space. I don't know, dude. How do I know what the penetration depth is? Okay, let's think of this in terms of a mesh instead of Minkowski sum. Let's say that the hitbox is a single point, and we're just dealing with normal meshes. And it's like, oh, okay. So the position, it's the position, right? I just say like, oh, is the position less than the d value, and that's it, right? Who knows the position? Is it like state dot body? Oh, come on, dude. Body. Doom. Position. EX, right? Oh, God. Trajectory? God, with acceleration. Oh, my God. Oh. Oh, body equals. Oh, wait. It's exactly this line. Like it just whatever. Position equals to gabagoo dot position. There you go. And then so that is the current body position. Depth is equal to dot and then minus d, something like that. Right? Holy moly. Okay. Okay, is that right though? N dot position minus d. D's. My name is D's. You're like, oh, so it's like negative values. Yeah. Okay. So this is like negative. We could just do d minus, and then we get print. We could like enumerate, I guess. I don't keep track of the tick number. Am I allowed to just pretty print this? I think I want debug print. 32,128. Iter, please. All right, that was tricky. All right, so I'm printing the penetration depth of the of all of the contacts, the current contacts. So when you land on the ground, it should tell me how far into the ground you are, and like it should just be 0.000000000000000 with like a bunch of zeros, but I think it's not. This is making me sick. Why is it rebuilding? Oh, it's because it's an old version. I guess I should have rebased it. There were problems. Look at that. Okay, but it's not. Oh. Well, now it's 0. And it still happens. Let's see. Oh, that's so cool. That's so cool. So it never actually adds these to the contact list. That's super cool. Isn't that cool? Oh my god. Look at all the zeros. But as we can see, it's actually not 0 sometimes. And it's also not like changing like I was expecting. Hmm. Hmm. All right, let's actually pop, lock it, and drop it. We'll go to here, please. Hello? Oh, I pop. Ah. God damn it. There we go. Good lord. Okay. Run the track. I want to see it again on the latest code. When you press the wrong button in Git. Oh, I should fix this. I think I saw how to do that. How come it's the same number? Is it just like random? No, it's like when I'm... Okay. Okay, it has nothing to do with the mouse. It's when I'm holding the walk. Okay. Which is kind of expected, because like the walk is pretty janky. And it like, it doesn't... It doesn't like special case the surface. You can like walk up and down inside the object, no problem. It just kind of like is designed to like maybe probably not do that. There's no like type level safety or like uh, degrees of freedom axes or something like that to prevent you from actually intersecting using the walk code. So I guess you just like sometimes you walk. I find it very interesting that it's the same every time. Contact number 0. Funny. Contact number 1. Hey, it's changing. You see it? Three contacts. Holy moly. Yeah, so that's the walk code being bad. Zero, 1. Pay no attention to what's behind the curtain. Mind-bending code. Oh, I love how fast it is. Precise it is. Look at all those digits. Nanoscopic precision. It's very fortunate that I can just figure this out from scratch. It's very not obvious. I am already getting mentally exhausted. Time to heat up the coffee. I'm thinking I should dump more sugar in. Okay, no legs up. Just keep your legs down. Keep your back straight. Posture check. I say MD escape. I should keep this comment. I guess I could like squash merge ish. All right, what are you doing? Get out of here. Squash merge. Cool. And then revert twice. Yeah, I guess I could cherry pick. That'd be nice. Alright, and then bing bing bong. Okay. Is that what I called it? Yeah, implement. Okay. I think I just hard dingus this branch onto there. Because I don't think I need all this, like, history here. Ooh. Right, I had this entire, like, Scoobert machinery. Yeah, actually, gonna keep it, but simplify it. What happens? Wasn't that already the code? I have no idea. Oh no, this is on MD escape. Right. Nice. All right. Wait, what? Wait, what? Okay, think. But but don't, but but dump, but dump, but what? So when I jump and then immediately press the key, it stays 0, or it lands exactly on the surface. But if I press the key just before I land, it doesn't land exactly on the surface, but it doesn't sink in either. But dump, but dump, but dump, but dump, but dump. Hmm. Um. Wait a second. Wait a second. Okay. Jump forwards. 0. Oh, okay. Jump backwards. 0. Okay, it's backwards. Uh. I need a gaming escape. Ice. ISO. Am I allowed to play the game? Or is it gonna lag the stream? Will the NVIDIA driver be blessed today? Bless me today. I should totally get good at this map. It's a fun map. Ugh. Man, that math is hard. Craziest math I've ever seen. That's not true, but it's the craziest math I've ever tried to engage with and tackle. Ah. I'm immediately thinking about giving up. To never give up. Not giving up, but like working on something else, which is procrastinating. I'm like, oh, I can't do this. I'm too stupid. Oh, okay. Oh, come on. Going around the corner for a platform is really fun. Theory of mind? No. Object permanence. I believe that the platform is there. It will be there to support me. Okay, so how do I? Oh yeah, you go around the corner, don't ya? You like, it's like over here. Yeah, yeah. You go from there to there. So it's like. God damn, that's fast. Let's see if I can like speed it. Damn. No. Yeah. I R'd. No, no, no. No R. Okay. I just do not know where it is. Oi! I got it. Let's go. Okay. Did I actually jump on it or did I like jump on the side-ish? Crazy shortcut. Crazy! This is horrible. Oh man. These platforms are unions. I remember like how sucky it was to implement that. But like now it just works great. It looks great too. I don't really understand how it works so well. Like I did implement everything, but like, oh yeah, and then these are the like magically fall through the ground platforms. That's a bug. I think it has to do with like the length of the platform. What the? It's a very small edge case. The platforms are like just slightly rotated. And then the math just goes out the window. Wait, what happened? I must be up here, yeah. There's even a crash. If I go over here and then bump exactly like this, it can crash the game. Well, it's not doing it, but I know it can. Very specific. I wonder if the escape algorithm helped. Because it's built right now. The escape algorithm is built in. Where's my crash? Crash the game! Infinite loops. It dies. Died. Wow. Very, very mentally exhausting work. The hardest. The absolute hardest. Ugh. What to do? What to do? How do I progress the issue and like write a test that I can like run and it'll make things better if I run the test, or like prove the invariance of the algorithm and like, oh, it turns out actually this was never true in the first place, so that's why this and such isn't working. I feel like I'm fighting multiple bugs at once here, which has happened before, where like there's an issue that where I clip through the ground or whatever. Hey, I beat the map in, oh, nobody will ever know what the time was because of the spam. I wonder if the MD escape is what is preventing the infinite loop. I don't know. Do like this map. I don't have no clip. Do I not have no clip? Wait a second. I do have no clip. Am I stupid? What the heck? I did implement no clip. What a god. Urgh. So where am I going? Whoop. Yes. Did I miss it? Yeah, I went too far. Right? Yeah, right? Yeah. It's, uh-oh. What happened? Yeah, it's up here. It's up here. Yeah, infinite loop right here. Boom. 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 Man. It wasn't, I don't think it was over here. It sure is buggy. Yeah, the math works quite well when the parts are axis aligned, or like in like arbitrary rotations, but not when it's very nearly axis aligned, which it shouldn't be, but I still need to make that work in every case. Oh my god. Oh. Okay, let me read more about the bug. Unreproducible. Right. Simultaneity breaks physics. I said this is closed. Temp. It was removed. Let's go, let's go, let's go, let's go. I'm so happy about that. 11 whatnot. It's right here. Yeah, yeah, yeah. That's it, right? It used to be busted, and now it's not. Excuse me. BVH sample AABB, right? Yeah, this is it. BVH sample AABB. So I was doing like, oh, for each collision. Oh, no. If there is a collision, map the time and like make sure it's goes into the future. And it's temp question mark. And now it's totally gone. Mm. You love to see it. Ugh, my back. It's really cool. Next move instruction. Next strafe tick. Currently touching objects. And then it chooses the axis aligned bounding box to sample from based on that. Oh, dude, it should totally be an if statement of like either sample AABB or traverse the BVH if the trajectory segment it needs to scan is huge. Hell yeah. But like meh 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 meh. It's like meh. Wait, mutt. What do you mean mutt? Why is it mutt F? Are you trolling? Oh, is it because it's recursive? Ah, okay. Fnmut. Uh right. I would have to say like mutt F there. Whatever. Nobody cares. Okay. Love it though. Code fixed. No bad code. Temp is gone. This was the bug. Like, come on, dude. Just like, what? I don't. Yeah, it's very hard. Very hard. I I did get into it though. I am into the mind set. It's pretty hard. Why is this expect dead code? Oh, the whole call crap. How what's my surf fix? Fix surf. No way. Bow checker hand holding. You what, mate? Use push planes. Not quite. Push planes. So that's like the contact normals that are currently that are currently constraining your velocity, such as a surf or multiple surfs that you're like nuzzled into. And if they were not there, see, this is constraining your velocity, but there's also your acceleration. set velocity call. Like, you're kind of like currently resting on certain things, and then when you like have your velocity changed, you can move away from things immediately. Did I unsafe in this? Collect. Oh, equals to. Are you kidding? Like, oh, I have a list of pointers. I see. Yeah, I worked hard to make it into references, and then this is very goofy. Array vac. How come I want a minus like that? Where does I come from? Oh, goodness. Yeah, so okay. What's going on? I have two major bugs. You fall through the ground, you fall through surfs. So this was my attempt to fix falling through surfs, but it doesn't really it's not really the right it's not really doing the right thing. I kind of like don't remember what the right thing is to do. So like how do you constrain the velocity while also taking into account acceleration constraints? Because like if you like suddenly change velocity, you're no longer on the same trajectory. Interesting. I think that's an important point, that I create a trajectory. I wonder if that's the play, is to operate these constraints on the trajectory. I'm going to write that down. So instead of like, oh, velocity constraints, oh, acceleration constraints, I have trajectory constraints, and you constrain the trajectory always, or something like that. All right, where is fix surf bug? Surf is broken. Moving mouse calls surf contact. Um, idea. Think about constraining trajectories rather than just rather than velocity constraining velocity and acceleration independently. Surfing must work. Yeah. Um, 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 um. I wonder if this can be retained. Right, because it's drop guard. Hmm. Hmm. Okay, I'm just like deleting them one at a time. While light equals contact pop, there's no such method. Okay, so it's just like, okay, so it's not retain, it's like die. Drain. Why? Oh yeah, because like this function directly removes it. I don't know. I don't know. I wonder if I can. You know, I think there's algorithms. Yeah. It's kind of option. I wonder if I should remove default. Let's see. Let's see what happens. New min max. Yeah. So, oh, just BVH. Empty node. Okay, BVH node empty. Gabagoo. Interesting. Yeah. Yeah, nodes collect vac. Okay. Hmm. Mm-hmm. Yeah, we need to be like special. But like, does that make sense to have like no founding box? This is, it has to like be guaranteed to have objects, basically. It's a list with something in it. Is that the only place I use that though? That's very interesting. I would love to remove that someday, but seems like that's a bad idea right now. Zero. Do love. Good job, good job. Stateful strafe. Hell yeah. Bug fixed. There was a bug where if you set the tick rate to 66 ticks per second, it would break. And it was because it was designed wrong. It was designed as stateless, but zero time events are allowed in this physics engine. So what can happen is you're not touching something, and then like time passes, and then you're still not touching, and it's like does something else, and then now you're touching after 0 seconds. So it does something, and then 0 seconds later it starts touching. That's like a zero time event. It has to handle something in 0 seconds. And you can have an unlimited number of things happen in 0 seconds. It sort of just generally doesn't happen. You need to contrive a setup to make n things happen, such as imagine you have an inverted cone and you like fall into the bottom of an ice cream cone, and then you collide with like n surfaces at once. It's kind of contrived. Really what will happen is you'll collide with 3 surfaces, and it'll like pick some good ones because it has a good algorithm. But alas. Next. Do we have any? What if there's just like clippy stuff? There is. Oh my god. This function has too many arguments. You and me both. 13. Yeah. Box union data. I don't think so. Us. Minkowski 386. We'll take a look at that. Len. Oh, Len. Wait, Lynn. I mean, it's ugly. Like, I can see why I did like that. Okay. Ew. Oh, it's done there as well. Skip, take, meh. Uh, as. Yeah, into. True. True, true. Mm. Okay. Is it mesh query? Yes, it is. Okay, we can say into directed into undirected. Um, no. Or default. 916. Isn't that, I don't know, 916-893? Is it gonna know the type? Yes, it is. Sure, whatever. Okay, another freaking one of these. Who did this? New Bytemuck graphics. Line 14. Real. Shut up. For every single argument. Yeah, this is not a problem, my guy. Complex type. I mean, that's the point of into inner. We need like fields where you're only allowed to take a reference and stuff. I guess. Well, no, that's it's like getters and setters. It's like, yeah, it's like automatic getters and setters basically. So you can like only allow getters. I guess that's maybe non-obvious usage. What do you want? Oh, I see. Time. Real. It wants display. Yeah. That's a pretty goofy implementation. Do I use it though? Strafe. We'll see, I guess. Should be good, just like this. Do you get optimizations for this? I have no idea. Alright, see a chump. Who died? String literal. Yeah, okay. Alright, bruh. Alright, well, apparently, there you go. Silly. As refster, right. What you doing? Empty line after doc comment. Okay. Oh. Okay. Yeah. You right. Okay, fixed 8155. Surely. Real? We love macros. Go macros. More or default, eh? Lud. Lud. The la 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 la. La 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 la. 665. Boom. Da da da. 533. Huh. Function has too many arguments. It's a C-frame, my good man. Yeah, Scooby. Clippy, clippy, clippy. I see. little bit crazy. Clippy, clippy, clippy. All right, let's look at how to make a dingus from a dungus. The freaking app active event loop BS. App. Freaking Android, bruh. Hell is this? It's just. Oh, it's not a trade. Okay. How do you get one of these? Run. Fin. Goddamn app. About to wait. T. Goober. Yeah, there's a reason I haven't ported this yet. What the hell? Like, the only reason you have to do it this crappy way is because of Android, as far as I can remember. So run, yeah, app. So it's like a helper guy. Oh god. Okay, I see. So app is like a goober that does this. Okay, so basically I don't want app. I want no. You literally need option. Hate it. Give me type state every day. I don't want to like check if the window is made every frame forever. That's just stupid. Let's heat up this drop of coffee. Why is it like that? It's because of Android. Yeah. That's not tasty. Do I have cheese? I do have Yeah. Well, in the examples, win it examples. Never mind. Oh, there it is. Game. Hmm. Can we like go there instead? Okay. Cool. I just won't see the examples. I remember that there's optional values. I just don't want that. I don't want to do it. I don't want to do that. So, when you do the thing, you only get reference event loop. So I can't like run it until there's a frick and then run it again. You can only do it once, so you're forced to use option self. Well, can I like custom until I get that and then continue? How do you, how can I run the event loop like full custom until, I don't know. such a mess. Web, okay. Why? God. Delete all operating systems. Ugh. Not portable. What does that mean? Oh, it's another goober. What do you want? You what? What is this? Event loop. Window target. Huh? Linux. Oh. Ugh. Oof. How? Why is there two? What does this mean? What? Oh, it's a like crazy macro. Okay. Okay, it's a crazy macro. Okay. So this is like it's there twice. Okay, that's just insane. Okay. Wow. Wacky. Okay. Um I seem to remember that basically what you do is you like have option window in your app, and then every single time something happens, you check to see if you already made the window yet. And that's what I don't want to do. Thumbs down. Eh. I'm not sure that I made any progress here. So, I mean, maybe that would be helpful for this. Constraining trajectories. Yeah. Essentially, you change your trajectory. The trajectory is... This is a body, I guess, not trajectory. What's with the new setup? What new setup? Do you mean like in the last like 3 months? All I did is I turned the computer around. So the camera used to look out that way, and now it does not. Basically, I have a roommate now, so I want to like not have the camera just like observing the living room at all times, and like allow the living room to be used for living. Fellow surfer. No. I think it's like private. I can't believe how niche this bug is. And like that I actually found it. It's closed, but it's not closed. Let's see. Where am I? What is this? Okay. Build it, build it, build it. Why is it so crazy? It's like, oh, that's why. Okay, so I want to see if you still fall through the ground. I think you do, but for a different reason. Time for relaxation. What? Why did I lose so much speed? Oh, I forget. Crap. You can do that. Damn. Alright, we're gonna go. Oh, wait, what? What? What was that? Why did I clip into the ground? Damn. Alright, so it's on the last stage, and I just want to play the game. I've wanted to play the game for like 2 years, but 3? Well, I mean, that's why I'm making it, is so that I can play it. It's a game for me, but it's so hard to make that I've just been stuck for 2 years. And that's what I'm working on right now, is unstucking it. The hardest part, I'm just directly attacking the most difficult aspects as best as I can. But it takes a lot of mental effort, so it's like quickly exhausting me every day. But I just have to come back day in, day out, day again, next day, and the next day. Which is what this break is for. Take a break. Yeah. Okay. That's a super fun route. Nice. Nice. That's difficult to hit. Ah. Ah. Why is it like doing like that? Okay. Can I hit it? No. Okay. Left. Oh. 2 at a time. 2 at a time. Nope. Okay. Ah. Ah. Oh, I lost it. All right. Come on, bro. What? Come on. Okay, so this is the last stage. So I'm going to check to see if you still fall through the ground when you hit the boxes. Oh. Oh. Okay, it is right here. Okay, so if I hit the box like this, it's okay. If I hit the box like this, is it actually fixed? I think it's not fixed, but it's like just rarer. I don't actually know. It looks super fixed, but it's not. Unlucky. It's like halfway fixed. Yeah. It looks so fixed until oh man, what a bug. It's really crazy. There's like multiple of these bugs that I'm having. Oh, I should totally try that. Let's see if I can do that. Are like caused by multiple things. Oh, come on. Yeah. And so like I fix one thing, but it still has another cause. Or like I can't fix it in isolation. It's like it's caused by both of these things. Ooh. Ooh. What about this? What about this? What about this? What about this? That is so much better than before the simultaneity fix. So it looks like simultaneity is perhaps indeed fixed, but there's another cause, and that's zero time. Zero time, I guess that's like kind of simultaneity. It's not necessarily simultaneity because like you can, whoa, what happened? Whoa. Oh my god, bruh. Get me in there. Oh my god. So this floor is like slightly angled. That's like the cause of all my woes is like slightly angled anything. It's because the math is so exact that it like just doesn't quite work, and then you clip through the ground. Ah, well, there's the other bug. Bug still happens. Confirmed. How did I do? 638? Isn't that like a really bad time? That's not the right website. Yuck. Rock. Yeah, 205. Note that this is the same graphics. It's this website is reusing the graphics from the Strafe client. I'm not using Winit. Crikey. That's very quick. Could cut that corner better. So I wanted to think a little bit about the comment that I wrote. I hate that skip. It's a stupid skip. So what's the comment that I wrote? Oh. Constrain trajectories rather than individually dingus or dongus. Right, but it's kind of like, oh, you only changed the velocity, or you only changed the acceleration. Wee. Wow, what a big jump. Super cool run. Okay, I think I'll start with a new branch. Constrain body. Oh my goodness gracious. So, physics constrain. Oh, whole word. No, no, no. It's just anything. Okay. We don't have body. Ah. This is generating the acceleration. What? Body only has velocity, right? Oh, body has wait, what? Oh no, it's a trajectory. Okay. Yeah. Okay. Body only has velocity. Very good update. Delete body.acceleration. It's not a part of the persistent state. Fixed a lot of bugs. Right. So, okay. Raw. If I just say if it's just the raw acceleration unconstrained, how is it used? Methinks. Touching constrained velocity. I wonder. Yeah. So I just go like, oh, it's. I wonder if it works. Just base acceleration, unconstrained. So this isn't constrained. Let's see. Real? That's the only one I get to delete. Okay. Only call site. Allocation. I worked really hard to make it references, and then I need the indices. God damn it. Right. It can also be used for constrained position if you use that. Am I just using it wrong? I got no idea. Self is touching, right? Very interesting. So now where are we talking? Set velocity. Set velocity call. So I could use push solve here. Set position. This is not correct. It'd be nice if I wrote down what I considered to be correct 2 years ago. Wait. Did I seriously only write that? Whoa. That's a year ago? Oh, 2 years ago. Okay. Yeah, no. That was the guard thing. What was it called? What did I call it? Lifetime guard, lifetime. Bar checker hand holding. I think that's what I called it. Fix surf. There it is. Bar checker hand holding. Touching contacts. Lifetime. Because I want to hold it immutable. But it doesn't actually matter. That makes sense. Constrained acceleration constraints? Continues to hold it. It's kind of goofy, eh? Constrain acceleration. How? So this was, it was sort of implicit. It was like implied by this function call. But then now this is the function call. Body with acceleration becomes trajectory. So it's like constrained as it's constructed. So I would want like freaking type state or something. Just predict collision end. Like unconstrained trajectory or something. then the trajectory is valid while I hold an immutable reference to state. Trajectory holds a lifetime? Sure, I guess. Yeah, so kind of gooby though. Like, who cares? Trajectory is only valid while the contacts are valid. Mm-hmm. Touching constraint acceleration. Hitbox mesh. Why is that so nasty? Minkowski mesh. For loop. Oh. Contact normal. So it's like going from scratch? Okay, it is going from scratch. Minkowski. So, honestly, why wouldn't I make it generic across the mesh? Contact mesh. Transformed mesh. Like, do this outside, and then just like ND. Done. Contact normal. So instead of like goo 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 goo, the mesh is generic. It's kind of not though. Oh, wait. Could I just hold on to touching state? Oh, but it would need to be mutt. Yeah, okay. I mean, that's kind of bad. I don't know. Have a mutable. It's a cache. Allocations are convenient. Okay, so constraining a body, only the acceleration matters. Constraining a trajectory. Ugh, why don't I? In order to construct a body, it starts out like unconstrained. Or something. Does this entail directed acyclic graphs? Do I need compile time type state? Well, definitely not. I mean, I can always implement it without it, but to make like a completely safe interface. No. No, it has nothing to do with it. It would just be like position velocity, body with unconstrained position, body with unconstrained velocity, trajectory with unconstrained acceleration, and then you would need to constrain it with type state, and then you're GG. Mm, it's tough because it's setting the velocity directly. So where was it using this? Like, there's a couple places, right? Body with acceleration becomes a trajectory. And then to constrain that would require more stuff. It's not right. It's not right. It's not right. Looking at this, so it's like instructing the physics how to operate. It's like, oh, dude, you touched something. You started touching something. And then this is like what you started touching. And this is when you started touching it exactly. And that's like a duplicate of the time in here, but more precise. But like that's I don't know. How do I say? And then like reach walk target velocity. It's also precise. Strafe tick. precise-ish. But the main issue is also that this is only valid if you're currently walking. So it's kind of like you would want a like stage and then commit API where like, hey physics, what happens next? It's like, well, if you don't change me, the next thing that's going to happen is you're going to reach the walk target velocity. You're like, you press W and you're accelerating, you're going to reach your top walking speed. But if you like stop pressing W before you reach the target speed, that's invalid. You're not going to reach the target velocity. And so this is then wrong as well because the internal state changed. So it kind of has to like hold on to an exclusive reference to the internal state. But it also can't. But that would also kind of like make it work here as well, because then you could have the time information. Commit. Next instruction. What would happen? Like, if I have a lifetime, what would happen? So I actually was able to make it for the card game, but it was a little bit wibbly. Validate. So valid instruction. Oh, so it's like stage instruction. Yeah. So it's like you have a move that you want to make and then it checks if it's valid. But really it's the other way around in the physics where it generates the instruction. It's like next instruction and then you get a lifetime and then it is a staged instruction option. So gabagool, it's like common instruction. So next instruction would return life. It would need to change into stage instruction. Yeah. So yeah, no, that's actually juiced because like this would be staged and you just go like go instead of process. It operates on this instead of self.process. It holds immutable process. But the problem with that is that now the instructions are not serializable because they contain immutable reference to the original source data. This is a smaller interface than I expected. There's only like 7 occurrences here, so maybe I really do just change my entire way of thinking. Next. Instruction emitter. Not true. Yeah. Stage instruction. The problem is that it's... Is that a problem? Stage instruction. I... Maybe that's it. Maybe that's the way. Some of that. Okay. So this is a total rethinking of my entire system. So then this would be stage instruction. Stage instruction. So it'd be like this is dumb. Time limit. Oh. Is it dumb? Like, why am I doing I here? Don't I just want like self? Like, why am I not doing it like this? And then you just do kind of like that. But how is it done here? What do I have? Who did this? Staged instruction. It holds a bunch of chunguses. So you have timed instruction, you have staged instruction. You cannot clone a stage instruction. No spaces. State mut s it's an emitter. No, it is an emitter, and then it only does dingus dongus if it's also a consumer. So this is like E. How does it work? Stage. Who did this? Huh? Process instruction. That's not real. So this is like, oh, I'm the guy. Stage instruction returns a staged instruction, and this is the implementation. Okay, I understand. It's a public type, but with private fields. Okay, here's how it works. Staged instruction, stage instruction. Next instruction. Okay, so next instruction, that's the way that it, like, it's like, oh, yeah, get ready to do it. Get ready to do it. I'm gonna do it. But then it don't do it. We got to do like this. So it's like, oh, um, do I need something? I don't know. No time limit. Instruction equals to this question mark staged instruction self emitter self instruction map. I mean, yeah, it's map, but like whatever. And that's the deal here. So I did then sum, but it was a Boolean value instruction. This isn't really, this isn't really right. What do you want? Takes one generic lie? Oh, I'm lying. Okay, self. What do you want? Oh, that's true. That's very true. I mean, it can be like this, because that's how it is. What do you want? Sized. Come on, bro. Oof. How does it work over here? Did I need sized? No. God damn it. Game. Did I need to make game size? How did I escape this? I feel like what you want is to like put the goop into the instruction. So you're holding the like mutable reference in there, and then you don't have this crap. E. Okay, so this is problematic because now you get the goop on here. So the whole idea was to have it be immutable. But now with a lifetime, it's sucky. So I need... Right. So, I mean... Let's look at the call site. So... Oh, reach walk at target velocity. Oh, ooh, reach walk target velocity. So, like... So what's the next way it's gonna move? So it's like, oh, it is possible to reach this acceleration. Whoa. And then it says, dude, the next thing that happens is you reach the walk target velocity. Realistically, what we want is to like hold a mutable reference on the target, and when you commit, it goes reached. You're using the borrow check to prove that it hasn't changed in the meantime, and it's like that. But what I hate is that now you have a mutable. Wait, can I? What? Okay. I want you to not change self in your function that provides the thing. So it's like, so the lifetime has to come from stage instruction, but then your function. Does that work, actually? That might work. Right. So that I can't pack it into the instruction. If I want a mutable reference this within the instruction and then just go, I can't unless this is a mutable reference, but then I can do anything. And I don't want it to do anything. That's, how do I like design it so that you can't do anything, but you can stage doing anything? Okay, so where's this guy? It's down here. So like, yeah, this is the, so see how I'm rematching it? I shouldn't have to rematch it. I should know, like, look, invalid, right? Wait, why am I matching? Check that it was valid. Yeah. So it must exist like this. And this is invalid. This is invalid. This is invalid. It's not proved at compile time. Same with this. I'm gonna borrow check. So I think this is like a little teeny weeny bit juiced. Timed instruction. I think that can go away and it just becomes like instruction. It's difficult. Yeah. So like the lifetime comes from the mutt, but then your function can't mutt. It's kind of like I want to upgrade your references into mutt because I have mutt. I have mutt, but I'm only going to give you a shared reference, immutable reference. And then you can then put your plan, write down your plans, give me your plans, and then I can upgrade your plans into mutable references, but you can't do that in Rust because that's borrow checker. What if I give you a reference to mutt? What happens? It's a shared reference. That's crazy, bro. I think that would fricking work. Is that what I do in the goob here? Look at that. Wait, no, that's not it. Oh. I think it will work. You can I don't know. I don't know. I do not know. I do not know. So this we want right here. So this is uh-oh. Okay, are you trolling me? Oh. So I want, that doesn't work, does it? I want you to be able to write down mutable references, but I don't want you to be able to mutate. There's probably a way to do this. I'm probably just thinking backwards. I think it's limited. I think I can't do this. Unless I'm just not thinking big enough. Need like freaking trait ding dongs. Higher rank trait bounds. Yeah. Like, I don't know how to do this without saying my there. Are you trolling? Candidate is defined. Liar. 0 generic arguments. Okay. Yeah, like why is there even I, my guy? Frick is that? T time is T. Like just don't. With the generics, just don't. Or D, bruh. My boy, do you want like self? Oh, not such field. Goodness. Like that or something? What are you trolling me about? What bound? This bound. What the hell are you talking about? Is it just trolling? Why is this underlined? Oh, I didn't say where self. Okay. Cool. All right. What do you want? E may not live long enough. What is that? Is that how you do it? Alright, bro. Sure. So, time limit. Sir, do not mutate. I know I'm giving you a mutable reference. Do not mutate, sir. Ah. Like, it just looks useless. Wait, it is useless. It is useless. This is a useless interface. Oh, clipboard broke. Nice one. Thanks, Ed. Actually, no. Yeah. Oh. Right. Right. That's why it was a generic. Is because it can consume different kinds of instructions. So there was a reason for it to be generic. Can you emit multiple kinds of instructions? I don't know. Glad to be rid of time though. It's generic. Time comes with the instruction like, oh, it's all confusion. I don't know how to design this interface. The idea is that I give you exclusive access to the object, but you're not allowed to change it. And then you say how you are going to change it, or like you okay, it's like a double lock-in commit thing where like you say that if I change it, I'll change it like this, and then you pass that over, and then I either make the change or don't make the change, depending on what happens in real life. Like, did you press W or did you not press W before it did the thing? Right. So yes. When you okay. When you press W or don't press W, those are the two things that can happen. Well, there's obviously more, but it's like every time you don't press W, it's idling. And it's like, okay, game, what happens next? And then it goes like, well, the next thing that happens is you're going to hit a wall in 0.3 seconds. And that's like, it has now committed that that's what's going to happen. And then there's like a dot commit on that action. It's like, that will like apply the change. It'll make you hit the wall and then you start falling or something. But it has to compare with the current time. So like, dude, what's going to happen next is you're going to hit a wall in 0.3 seconds. And it looks at the current time. It's like, well, it's not time yet. So then it drops it. Or, oh, yeah, no, that happened before we pressed W. So then it hits the wall. It commits to doing it. And then asks us again, okay, you hit the wall. What happens next? And it's like, there's nothing. Nothing is going to happen next. You're just going to fall into the void forever. Nothing happens next. That's an option. That's why it's optional here. Because it's possible for nothing to happen forever. But I do have this time limit. So like you can say, oh, there's no limit or something. But like, that's like the procedure. That's what's going on. It's like, game, what happens next? And it's like, here's a staged instruction where I'm going to hit the wall. And then it checks the current time. It's like, oh, well, that hasn't happened yet. It's always like catching up to real time. It's the illusion of real time. It's always behind by like 10 milliseconds. 1 to 10 milliseconds, which you can't notice because you're only a human. Do not mute it. Do not mute it. How do I like? It's like a handle or something. All right. It's AI. I did my thinking, and I couldn't figure it out. Now, the thinking becomes outsourced. Please tell me what to do. I have almost no confidence that this will actually give me something useful. It was way simpler with the card game. The AI was able to come up with the same thing that I had already come up with. I'm very interested in making this work. Have a nice little API guy. Okay, so let's see. Physics, physics, physics. I am the physics. Okay, so cool. Internal instruction. Giga time. Super giga. Okay, let's just simplify it a little bit. All right. Yeah, simplify. Okay. This is also kind of like rubber duck debugging, where like I'm talking to the computer, and as I think through the problem, I hope that I will find the solution. I am trying to design an API where for a state machine where you ask the state machine what the next thing that happens is, and it returns the staged action which is ready to commit. Dot commit. We can just say dot commit. And we'll apply the update. The tricky part is that it needs to decide whether or not to commit, but the staging step cannot mutate the object, the state machine. In order to create the staged action, the staging step requires itself, which allows for mutation. The idea is to avoid rematching the staged action when committing. Well, no, does that, it literally has to. You literally cannot. AI, please save us. Rematching state internals when committing, since only a certain state is valid during commit. That's worded poorly. Okay, so like, oh, we internal, when the physics asks itself what happens next, this is how it's represented. Okay, so I think the deal is that this one, I have this wrapper type staged instruction that like means it's ready to go. But now I'm trying to bake the staged instruction into the instruction itself. And so it no longer makes sense to have this wrapper type. So interesting how the requirements change between different projects, and like just got to start from scratch, design your stuff from scratch. Like I every time I come up with this stuff, I'm like, "Oh, this is the be all end all. Nothing could ever make this better." And I find little holes. And it's like, well, actually, if I have this staging API, it would be better. This is dumb. This is dumb. We should definitely go back to instruction. Time is kind of dumb. Yeah, it's like bound. I don't know. So it's generic across the instruction, but exclusive. Let's look at the physics code. Okay, this is dumb. Put it back. So like as it's going here, what happens next? It is like it tells you exactly what happens next. At exactly what time. Internally. It's an internal instruction. Never meant to be serialized, but I might serialize it anyways for speed reasons, because if you serialize the internal instructions, it means that you don't need to recalculate them, even though they're deterministic. So it could improve playback speed for, like, if oh well, no, I could do that in memory actually. Calculate once, slower on the first go around. Yeah, well, but network serialization, like displaying other players' motion. I'm on off track, tangent. It's useful, and this will ruin it. The API they're making will ruin it to some extent. So collecting instructions, just polling, no mutations. See what happens next, bro? I'm going to search this up. Rust upgrade immutable reference to mutable. No, you can't. You can't because it's like it's holding immutable all the way down, and then I'm trying to like call the next function which has mutable, but now you have two at the same time because this came from the same one. It doesn't work. Let's see. But like, it makes sense in my context. If I have a generic like dot upgrade, but it just doesn't work. That's what I need though. Very bad function. So it's very specific. It's not general like this. Yeah, so like, God, you're freaking loud. So it's like you're building a mutation plan with immutable references, and then you upgrade the plan to mutable type situation. And that's instant UB. But there must be a way to make a safe API. Because like basically you start with you start with a mutable. Yes. When you call the function stage instruction, you start with this mutable reference, and then the idea is you like downgrade it for this, call the external code, and then you get your staged instruction, and then in the process instruction, you receive the stage instruction, upgrade. Oh, this is not how it works. There's none like that. Upgrade all of the immutable references in your stage instruction to mutable, and then go for it. And that's instant UB, instant undefined behavior. All right, rusty. Okay, so hi, I'm the guy. Look, I'm doing this. Okay, this. Oh, okay, we go from the beginning. Is the current API without borrow checker proving that the state machine did not change. In the meantime, what I envision is for internal instruction to have a lifetime and hold mutable references to. I mean, I'm just kind of, I don't know, like I really don't know how to explain this super good. Apply an atomic state update. Apply an atomic state update. So what did I do over here? I had staged instruction, consume. Yes, that's right. And commit. So commit called process instruction. So you implemented process instruction from the valid instruction, and then so you couldn't call this function. This is only, yeah, this is cheating. R. Instruction consumer. This is dumb. Stage instruction. Yeah. So it requires a dingus emitter. Staged instruction. Emitter has next instruction. Stage instruction is consumer. What the hell? Right? Yeah, what? What am I doing? So stage instruction only dunks. Huh? Consume without emit. Alright, show me all the dingus. Process. Who are you? Mouse interpolator. Oh my god, bro. Instruction consumer, instruction emitter. That's the trait itself. Okay, and then I use the functions there. Session, consumer, mate, emitter, bing, but it's a consumer for two types of instructions. Lifetime. And this way. This wouldn't work with what's going on because it doesn't emit its own instructions. That's it. It's instructed externally like a card game. But the card game is instruction valid. Okay, maybe instruction. Okay, so it's like, so there's two paths. Does that make sense? So it's like instruction validator and instruction emitter. It can emit its own instructions, or you can check if instructions are valid. W press, like, are my W presses valid? But like, pause. It just kind of doesn't matter for this. Like, session control instructions set paused. Like, just ignore it. If it's already paused, just ignore it. It just doesn't need this like super duper validation because it just can ignore it. But then if it's this, if it has this staged instruction, wait, whoa, hey. Does that make sense? If I do like, if I have some sort of external instruction and then I construct a staged instruction via a trait, I mean, that's the same thing. That's a validation. That's validation. I don't know. Okay. So I want to like provide an example of like rematching. Okay. Mainly it's, where's the guy? This is okay. a function internal to the state machine that emits the reach walk target velocity instruction colon rust and then we see the consume site. Okay, and it's like, oh, here is part of, here's the location where the emitted instruction is consumed. Notice how many variants are invalid state. Period. So the idea is to use the borrow checker to be able to have a staging API. Instruction staging API. This thought is somewhat incomplete, but maybe produce a flawless API to implement this idea perfectly with no mistakes. I don't know if I could be like tongue-in-cheek like that. Okay, so I'm interested in seeing prototype how this API can be implemented in practice, I guess. We'll try that. All right, go AI. Go AI. This is a classic problem in Rust state machine design. When you go VRAM. Go GPUs. Run my CPU. It's so amazing that I'm talking to my computer. I couldn't have imagined this 5 years ago. I'd be like, you're lying. You're lying. Command pattern with pre-computed data. Instead of returning an instruction enum, return a structured command that contains both the intent and the data needed to imply the intent without rematching. Exactly. Stage next action, stage action. So the problem here is that you have this immutable reference. Funky Beach Shack. Yeah, apply action, staged action. So you see, we've like lost the thing. This doesn't do any of the stuff that I was asking for. So you're like panic. The entire point is that it's impossible to reach the code paths where it can panic because it's been staged. This is nothing like my idea. The point of the staging API is to make the panic code paths disappear from the code due to the command holding mutable references to state machine internals, and then directly operating on the internals pre-matched i.e. the inner type of transient acceleration. Oh. Setting walk state dot target transient ding dong reached. Because the command held a mutable reference to the walk state inside the enum. All right, wrong. Try again. Big brackets. All right. You are absolutely right. Classic. Okay, so you know, I'm just gonna like boop. Is it possible to? Why don't I search it up first? Rust downgrade moot into immutable reference and then upgrade later. Re-upgrade later. Doubt. Yes. You cannot. Okay. Yeah. Structure like Bing cell. No. Reborrow. What's up? What's up, my good dude? Emulate reborrowing. What happened? Hi. Generalized reference is a type that has reference semantics without being a native reference like Singus and Songist. Given a ding reference of dong, viewer some objects. Reborrowing means getting an active over the own object, which renders the original reference inactive until it's dropped. The original reference becomes active again. Yeah. Hey, this fails to come out because we can't use a non-copy value I've just moved. What's up? Okay, always move here, it can't be used here. Worked around by unwrapping the option, reborrowing it, and then wrapping again. Why would you do that? Okay, what does it say now? Okay, it hasn't like done anything. Struct. Way. Staged action. Let's go. Stage, yeah, see now it's taking much self. Yeah, this is exactly what I'm doing. So like, oh, wait, it died anyways. Uh we don't need this. We don't care. No validity checks required. And then it does it anyways. What's this? Okay, usage example. Stage, commit, action? Oh, that's dumb. And that'd be action.commit. Oh, wait. Oh, it did it totally wrong. This isn't self. Yeah. So this is like the problematic one because stage. Where's the thing? What? There it is. Stage takes much self, but I want it to take. I want to not be able to mutate it. Problem is that since that stage is a trait member function, the API should be sound. Impossible to misuse. In safe Rust, sure. The stage function should never mutate self, but in this version it is allowed to because the function signature is myself. So ideally, stage would call take myself and then call a user implemented trait member function next instruction. I'm just gonna like do it. Stage instruction with self, and then upgrade immutable references to mutable references later when applying the action. And then now it's just going to write 700 lines of unsafe. It's like, oh, you can do that if you... This is a sophisticated design challenge. With the semantic purity, yeah. Mm-hmm. Mm-hmm. Okay, because another reference might still exist. That's right. That's right. Yeah, I like needed a compiler level like, well, no, exclusive. Yeah, no. It's like locked. No. It's like you just can't. What does it say though? Hmm. Yeah. Bad. Decide next instruction. Yeah, now you're rematching. Yeah. So interesting. I don't think this is it. What were those crazy things I saw once? I was reading a rusty blog post about a dude that works on the compiler, and they were talking about all sorts of like wacky reference types that you can have that are more descriptive than mutable and immutable, shared and exclusive. It's like pin, and they were also talking about like having more types of functions. Like you have const functions, but you could also have like no IO functions where you can guarantee there's no side effects. Pure functions. Hmm. Hmm. Semantic purity. Ah. Yeah, what I want to do is I want to be smart now, make an API that is impossible to misuse and impossible to misimplement. And then I just like mash the keyboard later. I don't have to be smart all the time. I have to be smart once. But it looks like I can't. Hold up. Oh, boop. What? No, it doesn't work. It doesn't work. I could wrap. Okay, I was thinking like this. I could wrap the type, wrap the mut self in a wrapper type that only lets you access an immutable reference. Or yeah. But then you can go ham and copy it, right? Yes. It just doesn't work. It doesn't work. Immutable in spirit. I'm also not sure about the instruction API final. Yeah, I'm like just like messing with stuff bound. It's kind of like config, I guess. It's generic across instruction, but he always uses the same config with the instruction. Config time limit. Config time limit. Yeah, no, it doesn't have to be a bound. It can be a config. Doobop. It's dumb, so dumb. Oh, make everything super generic. Oh, ooh, it's so generic. Excuse me. Methinks. Oh. Well, literally, it's a. I don't know. I'm lost. I'm totally lost. So I want to read that blog again. Rust potential features. Reference types, pure functions, blog. I don't know. Let's see. Was there something there? Enforcing a pure functional style. I wrote a blog post. Yeah, it's not there. Reference types. Pin. I think it was related to like pin semantics. I won't find it. It was on Hacker News. I wish I could remember some of the words so I could search for it. Oh, I know how to find it. Well, hold on, give me a second. I remember. Oh, there it is. My grand vision for Rust. found it. Boom, there it is. Let's go. What the hell? I don't remember it looking like this. Async. Function colors. Effect types. Type and effect systems. Functions which guarantee they do not unwind. Functions which guarantee they terminate. Holy halting problem. Let's go. Guaranteed to be deterministic. Not call host APIs. Yes, sir. Wow. Conscious systems. This is incredibly useful. Substructural types. Yeah. So there's affine types at most once. Linear types exactly once. Super cool. No more memory leaks. Ordered types exactly once in order. Stable memory locations for pin. New traits, move and forget. Forget unlocks linear types. Move unlocks ordered types. Temporal memory safety violation. Refinement type systems. Am I conflating? I think I'm conflating it with another one. Yeah, I think I'm conflating it with another blog post about pin. This is it, but I was conflating it with another one. Rust pin mutt. Gabagoo. I remember there being a table. Hum. I think it's actually straight up just like a different problem. This is good for the card game. Because it's a yes or no. This is valid. This is not valid. And like I'm using this to wait a second. I'm using this to upgrade. This is the upgrade right here. This is the upgrade from immutable reference to mutable reference, except the instruction does not contain any of that. You know what this feels like? It's like looking, like I was looking at it like this, and then I changed my perspective slightly. I've like rotated the inroads and outroads from the concept, and suddenly it doesn't fit Rust anymore. Trying to make the safe API. Where? Okay, I could, I could probably make this by like smashing ownership around. Instead of using mutable reference, immutable reference, actually just throw around the object itself. And I could box it and it'd be super easy stack. Box is super cool. Send something to another thread. So it would freaking move in to the stage type. Does that help? Well, actually, no. Because now your match is invalidated. Because you moved it. So you can't hold those mutable references. I can't believe how interesting a problem I came across by trying to copy the API from the card game. Config, you dumbass. Just call it time. Well, question mark. Goober function. Yeah, this should be stage commit. Stage commit. I want type state for a mutable reference that is convertible such that I am not allowed to mutate it. So it's like an exclusive reference without mutation capability. But you can unlock it. It's kind of like lock, unlock. Which is It's kind of dumb, but like, yeah. And then to keep it safe, it doesn't quite do it because like you can still like unlock it anywheres. You need to say who's allowed to and who's not and stuff. So it's not quite right. It's a little bit better and would actually work. It's still not quite right. Staging API is so hard. I am trying. Is it possible to? Must pin log. I see bhop. What are you working on? I'm working on a game engine. Bhop. Let's turn off the AI. This is it. So it has major problems such that you fall through the ground. Entire engine, not just Bevy. Yeah. But it works. Yeah, so like surfing worked because it was like bodged together. So yeah, so like I want it to be perfect and that's what's holding me back. It's like functional-ish. It's functional enough to play if you dodge the bugs. How are you handling collisions in physics? Full custom physics engine. I wrote everything. I'm doing parabolic ray tracing. Believe it or not. Which, that's how I coded myself into a corner. Whoop. Because now it's so complicated that I have to be a level 17 genius to solve the physics problems and fix all the bugs. Custom physics. Yeah, I've been like digging through it all stream. I wrote, do you know Roblox bhop? I wrote that. That's my game. It also has custom physics. Looking into box 3D. I saw that as well. It's fun that the guy that made box 2D, developer of Surf's Up on Steam. I have not heard of that, unfortunately for you. but cool. Or maybe unfortunately for me, right? Yeah, I've been working on this for way too long. I've just been stuck and kind of like procrastinating, not working on it. And so my goal over the next like 2 months or something is to like directly attack the hard problem and try to fix it. Attempt number 10 or something. Nice. Ugh. Anyways, so the bug that I showed you where you clip through the ground happens because of the internal representation of the contacts. So like right now I'm contacting the ground, so the contacts list length is 1. There is one contact, there is one object you are in contact with. And how does it store that? So it stores that as like the face that is touching on your hitbox and the face that is touching on the other object. And then it can calculate the normal vector on the fly as needed from that. But the problem with that, okay, face, that's not quite correct. The problem with that, okay, I didn't describe it correctly. Face, edge, or vertex. So there's let's say, oh, actually, why don't we do like this? Let's say this is your hitbox, and this is the platform you're jumping on. So it's like the vertex, edge, or face of the thing you're standing on, and the vertex, edge, or face of your hitbox. So it remembers that it's this vertex on this face, and that's how you're standing on it. I wish this was okay. This is like square enough. So like here's a vertex. So like imagine you're standing on this, and it's like it's this vertex on this face, and so like walking around works fine until you reach the edge over here, because it's like this is the vertex that's standing on this. So you reach this edge, you just fall off before you reach the edge. So what needs to happen, it needs to switch the internal representation to the other side, so that you can like have your toes off the edge on the other side. And every time you like walk off the edge, it needs to switch, and it doesn't. So what happens is like you walk off the edge in 0 seconds, and then you start falling, and then it goes to find objects in your way to find potential collisions, which we can actually go to the code and see. And it doesn't find it, is the problem. Because you are like flush with the surface. You're transferring from this side onto that side in 0 seconds, and so it's touching all sorts of edge cases, and it just doesn't work yet. Okay, so what are we looking at? Physics. Wow, physics. The physics. Okay, I think it's like a line 1,000. Oh my god, bro. What? Raycast? Alright. Nice one. BVH traversal. Where's the... Is this it? Predict collision end. No, it's right here. Okay. Next instruction internal. So this is like, hey physics, what happens next if the user has no input? So it'll go like, is there going to be a strafe tick? What is this? Next move instruction? Oh, that's walking, isn't it? Yeah. That's reach walk target velocity. So like you press W and then you speed up, and then eventually you reach your max speed, and that's reach walk target velocity. So that's something that can happen next. Maybe there's a strafe tick. Maybe that happens next. Maybe you're going to stop touching something. So this is predict collision end. So of the things that you are currently touching, are you going to stop touching anything first? So this is an instruction collector which replaces the instruction when it's sooner than the one that it already has. I gave Rust a shot, liked parts of it. I got deeper into C++. C++ is much more mature for game engine development. I've chosen it because I like Rust. Multiple collision faces. No, that's actually handled right now by the push solve algorithm. Okay, so what happens is it runs two physics ticks. It's actually tickless. There's no fixed tick rate. Back to back in 0 seconds. Got an ad break. Oof. Bruh. Twitch moment. Alright, we'll continue after. Back. Okay, what's up? Freaking Twitch. Okay, where was I? Okay, so this function runs twice basically when the bug happens. The first time it goes, yes, you're gonna stop touching something. Great. And then that's the result of what happens next. And then when it runs again, it's sampling the BVH, which is like a spatial organization data structure of like locating objects quickly within the world. So it's like, I am within this little bounding box. Run my function for everything that you find there. Sample this area. And then, so this code runs for every single object that you're about to collide with. So if you're already touching it, we don't need to detect if you're about to start touching it. Return. So grab the mesh of that model ID. Create a Minkowski sum of the two meshes. We don't really need to worry about this right now. And then predict when the two meshes will collide with each other, according to the current parabolic trajectory and this time limit. And then if there is a result, it's this Minkowski face thing. That's the like two fevs that I talked about, where like it's a face edge of vertex on this object and a face edge of vertex on this object, and that's how it remembers what you're touching. And that's the result of predicting the collision. So then it says time instruction. These two things are going to start colliding. And then that is the result for the second thing. But what happens is it never says that they're going to start colliding. And oh my god, it's freaking complicated. Fev crawl. Yeah, face crawler algorithm. Crawl along the surface. And then like, yeah, the big math happens. Because it's parabolas, we're doing quadratic solve. And then each mesh can we create, yeah, it gets so complicated. So I'm just trying to like get back into it after 3 months and like unstuck myself so I can like stop being stuck on the physics and start working on like leaderboards and networking and like replay leaderboard systems and stuff. The actual rest of the game. Yeah, so I'm very interested in designing the best possible physics for a skilled movement game. And so like normally what physics engines do is there's a like fixed tick rate, or fixed tick rate, and get my props again. So the objects in the world are like moving, right? But that's not actually what happens in the physics engine. They teleport to the next game tick and then check to see if anything is intersecting. And then teleport to the next game tick, check to see if anything is intersecting. Oh no, they're intersecting. And then it like pushes them apart and corrects the state because it like made a mistake. And things aren't supposed to be intersecting. But that's not how my physics works. My physics doesn't have a fixed tick rate. It's literally tracing the path volume and finding the exact time of collision. So it says, according to this trajectory, this object will hit in 0.327145 seconds, and it advances time to exactly that moment, and then applies the collision, and now it starts falling. So they never actually intersect. And you can have these chains of rapid events happen one after another, exactly when they happen. It like exhaustively catches up to real time and handles each thing that happens until we've reached real time. So what you expect to happen is what actually happens. Instead of having like weird physics interactions where like you clipped into an object and then it pushes you out the wrong way, kind of like you entered in this way, it pushes you out, and then you continue along like nothing happened. But really you should have hit the face because you hit the front of it. In all situations, what you expect to happen actually happens. And I believe that this is the best way to do physics for a skilled movement game. Remains to be seen. It would be absolutely terrible for a physics sandbox game because of the precision involved here. It like stops the entire world every time any two objects collide. But it's basically a one body physics system. It's not really an engine. It's only really paying attention to your player character. And you can't really have a pile of rocks. Like it could sort of be extended to do that, but it would freaking suck. Very custom. Trying to do everything with the actual game in mind from scratch. Yeah, it's challenging. Yes. My goal is to have this be like a gardening project, a programming garden, where I can stream every day and like work a little over here and work a little over here, and then fix some bugs, improve the leaderboards, and like fix some physics bugs and do this and that. But oh man, I've coded myself into a complexity corner. I made it too complicated. I'm literally not smart enough. Exact calculations. I wrote a whole linear algebra library, and like I don't use floating point at all. I'm using fixed point for world precision, for world positions, like where the objects are in the map. is like not a float 32 or a float 64. It's an integer, but it has a scale. So very small fractional numbers are representable. Fractional, well, yes. I mean, I have ratios as well. I kind of went a bit hard on it, but I think that's more representative of how objects actually exist in the world, because like floating point numbers, most of the floating point representations, half of them are concentrated around 0, the origin, but your objects are not there. That's not where they are. Your objects are like uniformly distributed around your game world. They're not concentrated at the middle. So floating point is the wrong representation. And you lose a bunch of precision, calculation precision, by using floating point, but you gain a lot of ease of use. Let's see, some like physics jank here. And these are pretty nice. They look nice, but then eventually I have to do like this sort of thing where I'm like rounding, or this is actually truncating. So like, oh yeah, I didn't even explain the insane part. So what I did is I made a number library that when you multiply two numbers together, you get a bigger number. So you have like a 64-bit integer and a 64-bit integer. And when you multiply them together, the result can be up to 128 bits. So it just returns those 128 bits. It just returns the result. So there's no such thing as overflows. There's no such thing as that. And it determines those sizes at compile time. So this is a huge one. What is that? 96 bits. Is that actually 96 bits? Do I have 32-bit? I thought I didn't have that. Oh, it's the fractional. Oh. 24, that's freaking huge. Oh my god, bro. Divide by 8. Okay, 8. That's cringe. So yeah, as you do your calculation where you have this normal vector and you do the cross product with another normal vector, it gets bigger. This is the fractional part. So it's 16 bytes, and 64 of those bits are fractional. So it's a bigger number. And then at the end of the calculation, which is completely exact all the way through the calculation, you then round it so you can write it back into the original type and like update your position through the world or whatever. It's definitely not as easy to use as floating point numbers, but it's really cool. There's all sorts of like edge cases that come up because suddenly you can hit a 1 nanometer lip and you like just run into the side of it. You just stub your toe on a 1 nanometer lip. Or like if the position of your object is an integer and you're like on a slope, like technically at the smallest level, it's like aliased to a grid. And so you're like moving along grid points, which like that's true for floats as well. But because you throw away so much precision all the time in every single calculation, it kind of just janks itself away. And then you have other issues. But with this, what does it count? Like, think about this. Imagine you have 3 objects adjacent to each other that are all the same size, 5 by 5 by 5. Imagine this is or I guess this is 4. So 4 by 4 by 4. Or no. There's a gap. So it's 4 units. There's an object here. There's a gap. And then there's another object over here. And so there's a hole here that's 4 units wide. And so theoretically, you would imagine that you could exactly walk through that hole, right? Okay. But if you have these like instanced objects in the world that are 4 units by 4 units, how do you represent that? Like, what I have is I have meshes. You just have arbitrary meshes, and then affine transform, like kind of like a Roblox C-frame, that also includes the size. Which voxels, which positions in the world are occupied by that object? So like, if it's 400 units wide, does it include all 400 units in that direction? But then also 400 units in that direction, but then also the 0, 0, 0. So you have like 0, 0, 0, 0, 0, 1, 0, 0, 2, 3, 4, 5, 6, up to 400. 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, up to 400, negative 400, this way. But now it's, okay, well, 200, I guess. But now it's 401 units wide. So you have these 2 pillars blocking your way. Both of them are 401 units wide, and you are 401 units wide, and you can't get through because it's like blocking you by 1 pixel on either side. So then what? Do I say like, oh, it's in between the grid points? No. I would have to say like, for positive numbers, it occupies the complete space, and for negative numbers, it does not. So like, you'd have like one little cube. If you have a 1 by 1 by 1 unit cube sitting at 0, 0, 0, it would occupy that voxel, that pixel, and not on the negative side. So only positive, 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 and not negative, negative, negative. This would be empty. So it would be like, it would have a handedness in the world. And then like, when you rotate things, oh my God, now you have to like have it occupy only the negative parts, or positive, only the positive parts of the voxel. And then this side is like, it's kind of like lifted away, so that if you have 2 objects that are rotated, they exactly mesh in along the rotated surface to occupy the correct voxels. Because like fixed point numbers, it's literally voxels at the smallest point. So I haven't really hashed this all out at the smallest scales and made sure that like you can like exactly pass a rotated object, even though like if you imagine like a Minecraft mountain, except it's like a flat slope, but it's voxels. So if you imagine 2 of those mountains coming into contact, it's like, but it's at the small scale, the nanometer scale, it should be able to just slide effortlessly, right? There's a lot to think about. I'm going to go to a slope surface and walk on it. I've basically been ignoring that. All right, here's a slope. So I can like land on it and then like walk on it and fall through it. Yeah. And that's due to these troubles. Wait, there's that. Wait, is it like strafing on the? Oh my god, it's this bug. Why is it strafing when I'm landing on the ground? Yeah. Only naive people would write their own game engine. Ay, 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 ay. It never happens on flat ground. You never fall through the ground. I said, and then it happens. But that's a different bug. Yes. Very. Oh, I'm not allowed to do this anymore. Interesting. Stream lag. I think I'm about fed up. That's enough brain racking for one day. I'm going to stay at it for like 2 months, hopefully. And I hope I can fix at least one of the big old bugs. That being you can't surf and you fall through the ground. I want to fix... Whoa! Oh no. Oh my god. Halfway through solving one bug, you discover 2 more. That's how it's been so far. Is like what I think is one bug is actually like 3 separate bugs in a trench coat working together to fail the unit tests and whatnot. So that, oh my, is it? No, okay. So that was, so remember how I said like I'm doing like exact calculations, and as the calculation grows, the numbers double in size because they multiply together, and then you get a bigger number, and then you multiply that with a big number, and you get a huge number, and then you multiply that with another, and you get a huge number, and then after at the end you round it and then write it back into the position so that you can actually move through the world. Oh, that's backwards. Yeah, that was what that lag was about. Is it's running a game tick for every mouse motion. So mouse motion is 1,000 hertz. Look at that. Look at that. So look at the FPS. 1,300 while I'm sitting on the ground. 2,000 while I'm in the air. So it's like it has to do a bunch of extra work to prove that the physics work in a certain way. So like the FPS drops when I move the mouse because it's running 1,000 extra game ticks. One for every mouse hertz update. Yeah. Just how I want it. When you're in the air, it basically proves to itself that it doesn't have to do any work, which is actually pretty fast. So it can run like 40,000 ticks per second, which is kind of slow. It's fast but slow. I could totally make it better. But like, I want to make it work first. In the Roblox game, there isn't these bumps in the road as you like slide down this, because the hitbox is rounded slightly, kind of like this, except really small. And so those bumps are really, really small. I could totally like turn it into one single mesh. You can kind of see a line here. That's because it's not exactly a single mesh. It's like generated from a bunch of different objects. So it's actually possible to hit the inside of a different object, which is bad. But that's actually part of the generated map, because this is a map from Roblox that I converted. Whoa, why did I hit the trigger? Oi. Oh my god. I don't make that. It's so close, but so far. Like I had all of these game mechanics, like triggers and everything, implemented 2 years ago. Some parts of making it are so fast, but then the physics are so hard to make that I've been stuck on it for 2 years. Roblox's engine has an unfixed mouse pulling performance churn bug too. I think it's different. It's more like, yeah, it's different. Same but different. It's because it's like, I guess not as optimized as I actually do want it to run. Nice wall clip, dude. I actually do want it to run like every mouse hertz. It's just not as optimized as I want to actually run the physics. God, I need to. I should take a look at that. Let's see. Yes. Okay. So think about this. So like, when you walk, you're walking in the direction that you're looking, but when you walk and turn, the direction is changing every single time you move your mouse. And how walking works in this game is that you have this like walk target where it's like, I want to reach X units per second in that direction. So then the walk target changes and it has to accelerate to the new target. And so the target is updating at 1,000 hertz while you're doing this. So that is a true update. That's a true the physics truly needs to change to be perfect. But that's different than the strafe ticks. So in the air, the strafe ticks are actually scheduled, and they run 100 times per second, interlaced with the tickless stuff. So it's the only thing that actually runs at a fixed rate. And what that means is that like the motion doesn't actually change immediately when you press a key. When you're on the ground, immediately when you press W, you start accelerating. But in the air, when you press W, it's like kind of delayed until the next strafe tick to apply the strafe movement. So what ends up happening is that the mouse motion doesn't matter. Only the mouse position before and after the strafe tick matters. So you can actually start dropping these intermediate mouse movements and be left with the same result, the same overall motion. And I'm going to use that to compress the replays a little bit, so that the amount of mouse movement is like 5 times less. And then I'll have like delta encoding and whatnot. There's a lot to think about, of course. Gosh. Revisiting this, it's just such a huge scope. I'm doing it for fun. It's like the reason I started doing this is because it's endless work, and that's endless fun. I love programming. But it'd be kind of nice to end up with a game at some point instead of it just being endless. But like even now, just totally worth it. The first year or two of work, just endless learning, or like very. I learned a lot, is what I'm trying to say. Making my own game engine, obviously, I learned a lot. That's the roof. It's a little bit demotivating to realize to be unsure if I'll be able to solve the foundation of the game and have it be like airtight, physics airtight, where there's no game breaking bugs. Did I really just botch that? Botch. Damn. Like the Roblox physics are not airtight, but all of the bugs that do happen are not game breaking. They're all like floating point bugs. So one of the bugs in the Roblox game is if you're on a surf, a really long surf, and you're like just kind of climbing the surf, slowly going up, eventually you will clip into the surf because it doesn't do any position corrections. And the floating point numbers means that your velocity is not quite the same direction as the surf normal, the surface of the surf. So as you climb it, you go inside a bit more and more and more. And you can actually just clip directly into the surf. You can have a surf climb so tall that it's impossible. Unless you do a swoop and re-land on the surf. And then it kind of like resets the like clipping. And I want that to not happen. I want to use fixed point numbers. The first map where that's tech to go further. Yeah. So those are the kinds of bugs that are on the Roblox game that I want to fix on this game. But I'm not there yet. I'm not at the point where I can actually start fixing those bugs. Because the fundamentals are incomplete. Such as being able to stand on the ground without falling into it. I just fall into the ground. Oh, don't clip into the ground. If clip into the ground, then don't. It took you 3 years to make a failure of a physics engine. No, it took me 1 year. 2 years to fail. For longer. The game basically was the exact same 2 years ago. This is about 1 year of work and 2 years of polish. The polish has fixed bugs. I have fixed physics bugs and other bugs. And like everything has gotten like slightly nicer. But those fundamental issues still remain. All right, that's enough. That's enough for one day. I wonder if I can make progress on solving it. Have you guys seen this? Last time I solved this, I said it was easy. And now, I have no idea how to solve it. Bro has 3 PCs. Do I? Oh, pieces? Do they have a name for that shape? Game? Key Ye Cube. It does actually turn into a cube. It just kind of morphs. And the number of permutations is actually it might not be that small because it's like it's kind of like 8 factorial squared or something. That's not that small, but it's dwarfed by the number of permutations of a Rubik's cube. Yeah, I gotta solve that one day. I mixed it up a couple days ago. The one you have. Oh. Other one on the table next to the floor. Oh, that's just a case. I see. You actually can see that stuff. I see. Yeah. Okay. The implied one, the one that's being used as a stand for the Wi-Fi. It is actually just a stand for the Wi-Fi. And then that's my server. It's got all my terabytes and terabytes of movies and stuff on it. I love piracy. I mean, ripping Blu-rays that I legally acquired. Yes. All right. I will come back tomorrow, and I will work on trying to fix physics bugs again. I need more salmon, more brain food. My voice is going. The staging, the instruction staging idea is really interesting that I came across today. It's so interesting that like it seems like it can't be implemented in Rust, or I guess any language, because like the whole point is for it to be a Rusty API that's impossible to misuse. But like you can only really make that in Rust. 5K in SSDs and hard drives? No way. That's $1,000 tops in hard drives. There's one SSD, but it's not used for cache at the moment. 1 terabyte SSD is like 200 now, except I bought it for $50 because I got it all before the disaster. I haven't bought anything since it started, since the memory and computer part in general price hikes. Nothing. I've bought nothing. Well, one thing, I bought this capture card that I'm using for this. Just so recommend that if you're having capture card problems, get one that works. Oh, every single time I started my stream, I would have to turn the camera off and on like 5 times to get it to like maybe work. Unplug the capture card, plug it back in. Now, I don't even have to think about it. It just works. And like it was slow as well. Like I would turn on the camera, I would wait 10 seconds for the capture card to think about starting. This one, it's like less than a second. Just so good. Elgato 4K capture or something like that. Let's go. That's the only thing I bought. I bought it for $120. I have bought nothing since the computer parts got expensive. I pretty much have parts I want. I would like a more powerful graphics card. I like fantasize about running big AI models and stuff, but like I can't afford it. What would be best case scenario is like AI companies drop into the ground and don't get bailed out by public money, and then they start selling the mountains of GPUs, and then you can get like a data center GPU for like $400. Yes, give it to me. Probably won't happen though. Probably they'll just get bailed out, and then they'll just all keep the prices high indefinitely, or for like 10 years or something. Surely. Okay. 10 years is not forever, though. Eventually, market forces will fix it. It'll like self-heal. Where like from the ground up, companies will be creating memory and GPUs and stuff to fill the void. But like, yeah, no, that's not a short or easy process. So AI will go the way of the search engine. 3 companies, all the other ones die and get gobbled up. I was thinking about this yesterday. AI is like leaky. Like what we see now is that open source AI models trail frontier models by about 2 years. So you go from frontier capability to being able to run it on your laptop, your beefy laptop, in about 2 years. And so like no matter how powerful they get, as long as they don't go Skynet, it does eventually become accessible. And it's kind of impossible to stay contained because all it takes is one person to share it. It seems very leaky and like it can't really be completely captured by these companies. It's evolving so rapidly. I am getting real hungry. I'm gonna need to make something. All right, so long. Very well. I'm gonna go eat, and then I'll be back tomorrow, and yap about this problem again, and maybe make some more progress. I wrote down some thoughts. It wasn't totally worthless day. It was a investigation day, just like the title says. Discovering how I did it, how I done it. It's a what is it? It's a murder mystery where I am both the detective and the murderer. Okay. Bye. Murder mystery tomorrow. Self-investigation. Bug.